Hello, my name is Hector Prieto.
I'm Ali Skolskaya.
I'm Jessica Schlossstein.
And I'm Jonah Pachenik. The article that we're presenting on today is Arthropods in Amber from the Triassic period. Three key concepts for Module 1 that are central to this article are stratigraphy, the fossil record, and adaptive radiation. Stratigraphy is the idea that that sedimentation will deposit rock in uniform layers according to age. This allows for archaeologists to take their specimens and categorize them by age according to the rock that they're found with. The fossil record is the complete catalog of discovered fossils. It makes up the complete knowledge of the tree of life that humans have today, and finding new fossil specimens can help us link other species to their parent species. Adaptive radiation is the idea that a multitude of new species can arise from a single species. Take, for instance, Darwin's finches. Darwin theorized that from a single finch that flew to the Galapagos, a variety of new species were able to form based on their food sources.
Scientists have found 3 specimens from the Triassic period. The Triassic is a transformative period in the evolutionary history of terrestrial arthropods. Because taxa from this period are much more modern in their relationship than our taxa from the Permian. Amber is an extremely valuable tool for paleontologists because it preserves specimens with microscopic fidelity, allowing uniquely accurate estimates of the amount of evolutionary change over millions of years.
This picture shows how amber fossils are formed. There are first trees, and the trees produce amber. As flies and insects come towards the trees, they get stuck in the amber. When they die, the amber perfectly preserves them. Due to the concept of stratigraphy, we know that as the trees die, at the same time, they form a layer of sedimentation in rock. When paleontologists come in and dig through this rock, they are able to find the amberized fossils from that time period. So, as they look through the rock, they were able to find the arthropods from the Triassic.
The first specimen observed was a Triassicaurus fetuli. It has a body shape of a vermiform, so it is worm-like. And it surprised scientists with its gnathosomatic infracapitulum. It already had a developed mouth, jaws, and the pharynx. And it has a fine annuli circumscribed in the body, so that begins to show the exoskeleton. Legs 1 and 2 have feather claws, and legs 3 and 4 are actually absent. The next organism was Amphizoa triassica. It has a spindle-like body shape. It has a gnathosomatic infracapitulum also, so it has also developed mouth, jaws, pharynx. It has the prodorsal shield, so that also shows its exoskeleton, and it has the wax-secreting lateral lobes. Legs 1 is there. It is slender tarsus, and it does not have a leg 2, but it was there.
When the fossils from the Triassic period were found, the paleontologists were surprised. They found that the gale mites in the fossilized amber were very similar to those of modern day. They had many of the unique characteristics that gale mites from today have. They have only 4 legs, 2 pairs, a segmented body, and their unique feather claws. The gale mites found in the Triassic period, 230 million years ago, also gave the paleontologists a better understanding of evolution. These proved that gale mites were the oldest of all the arthropods, and that the arthropod phylum is the most unique of all the phylums.
In conclusion, our discussion on the founding of these arthropods was greatly enhanced by our understanding of stratigraphy, the fossil record, and adaptive radiation. These arthropods were very helpful to the geologic timescale. They've proven very significant to help scientists understand the evolution of arthropods because of how developed they were 250 million years ago. Also, amber preservation have proved very significant in allowing scientists to view these specimens under a microscope with great futility. And our concluding thoughts are, even 200 million years ago, arthropods existed, exhibiting adaptive trait characteristics of the majority of gall mites today.